My name is Lanugan. I will present to you the problem 1 of Module 1, Lesson 2, Soil Properties. Module 1, Problem 1. As our sample moist soil has water content of 18% and moist unit weight of 17.3 kilonewton per meter cube. The specific gravity of soil is 2.65. Compute the degree of saturation. So, first of all, bago natin simulan yung problem, it is important to identify muna natin yung mga given para mapadali yung pag-solve natin ng problem. So, let's give the list of the givens. So, sa problem, makita natin yung mga binigay na value. First is the water content, which is 18%, the unit weight, which is 17.3 kilonewton per meter cube, and the specific gravity of 2.65. So now we have the list of our given. So mga formula na pwede natin gamitin, isa sa mga formula na pwede natin gamitin is yung derived formula ng moist unit weight. Dahil ang hinahanap natin is yung saturation, makita natin sa formula ng saturation is wala tayong void ratio. So, para makita natin yung void ratio, pero pwede natin gamitin yung moist unit weight. So, yeah, using the derived formula of unit weight of moisture unit weight, pwede natin ma-solve yung void ratio natin. So using this, so substitute lang natin yung mga given yung 0.80, 7.3 kilonewton meter cube, and 2.65 natin na specific gravity. When substituting this, makakuha natin yung void ratio. Then, and now may void ratio na tayo, pwede natin magamit yung isa pa natin derived formula para sa atin hinahanap na problem na compute the degree of saturation. And substitute natin yung mga value natin, makakuha natin yung degree of saturation na 61.7%. Module 1 problem. Saturated silt clay encountered near deep excavation is found to have a water content of 28%. Determine the unit weight of the clay in kilonewton per meter cube. Assume the gravity is 2.7. We have listed the given, which is the water content or the moisture content, which is 28% or 0.28, specific gravity of 2.7, and because sinabi dito na yung clay na encounter is saturated, pwede natin i-assume na yung saturation tayo na 1. Now, to solve the problem, ang ginamit natin ng unang formula is yung first derivation formula na relationship between the saturation and the vibration and the moist or water content. So, after using the derived formula, pwede na natin substitute na lang and makakuha na natin agad yung ating vibration. Then, and using that another derived formula ng moist unit weight, which is the moist unit weight equals to specific gravity plus the specific gravity multiplied by the moisture content over by 1 plus void ratio multiplied by unit weight ng water. Substituting the value, makakuha natin agad yung ating moisture unit weight, which is 19.26 kN per cube.
Hello, good day everyone. Today I'm going to give some example in Module 2 Soil Classification. So dito sa una kong problem, classify the following soils using the US Department of Agriculture Textural Classification Chart. So given dito yung particle size and distribution percentage. So A, 20% sand, 20% silt, 60% clay. Then letter B, 55% sand, 5% salt, and 40% of clay, and so on. So ngayon, titignan natin kung nasa ang classification siya using the US Department of Agriculture Textural Classification Chart. So magsimula na tayo. So sa una, consider natin yung soil A kanina. Mark down natin yung percentage ng 20% ng soil, 20% ng silt, at saka 60% ng clay. So kung makikita nyo dito, 20% ng sand, versus sand, 20% ng silt, and 60% of clay. So kung mapapansin natin, yung soil A natin ay nasa clay. So calculation natin, the classification of soil A as per the United States Department of Agriculture Textural Classification Chart is clay. So dito naman tayo sa B. Consider naman natin yung soil B. Yung sand sa soil B is nasa 40%, percentage of silt naman ay 5%, and ang percentage ng clay ay nasa 55%. So ito naman, 50% ng sand, 55% ng sand, which is dito banda. Yan. Then 5% ng silt. Ito. Then 40% ng clay. So makikita natin yung soil B natin ay nasa sandy clay. So calculation natin. So ano to? Parang final answer. The classification of soil B as per United States Department of Agriculture Textural Classification Chart is sandy clay. So dito naman tayo sa consider naman natin yung soil C na sinasabi na yung sand is 45%, yung silt natin ay 35%, at ang clay natin ay nasa 20%. So ulitin natin, yung sand natin nasa 45% dito banda. Then yung silt natin is nasa 35%. Ito, nandito na banda. Then yung clay natin is 20%. Yon. So yung soil C natin ay nasa loam. Therefore, the classification of soil C as per the United States Department of Agriculture Textural Classification of Chart is loam. Another one, consider naman natin yung letter D. 50% sand, 15% silt, and 35% of clay. So sa soil din natin, yan, 50, 15, then 35. So napapansin nyo, di ba? Nasa pagitan siya ng sandy clay at ng sandy clay loam. As in, nasa gitna, nasa boundary. So calculation natin, the classification of soil D as per the United States Department of Agricultural Texture Classification Chart is sandy clay and sandy clay loam kasi sumakto siya sa boundary. So dito naman sa soil in natin, yung sand natin 70%, 15% silt, and 15% clay. So nasa sandy loam. So yung soil in natin is sandy loam. So yung soil F naman natin is yung sand is 30%, yung silt 58%, and clay is 12%. So nandito banda. So yung soil F natin is silty loam. So sa soil G naman natin, which is yung sand natin is 40%, yung silt natin is nasa around 25%, yung clay natin is nasa 35%. So nandito siya banda. Kita natin, nasa clay loam. So yung soil G natin is clay loam. So sa soil H naman, tatlo na lang. Mapapansin natin sa soil H, 30% sand, 25% silt, and 45% clay. So nandito siya, nasa baba ng clay. So yung soil H natin is clay. So soil I naman natin is 5% sand, 45% silt, and 50% clay. So nandito siya. So yung soil I natin is silty clay. Then the last one, yung soil J natin, which is loam, na nasa sand is 45% sand, 45% clay, then dito banda, then 10% clay. So yan, yung soil J natin is nasa loam. So sa problem 1 natin, yung pagkatapos natin classify the following soil using the USD Department of Agriculture Textural Classification Chart. So nakuha na natin yung result. Yung soil natin na A, B, C, D, E, F, G, H, I, J ay nakita na natin sa classification chart pagkatapos natin i-plot. So yung A natin clay, yung B natin sandy clay, yung C loam, and D yung sumakto sa boundary ng sandy clay and sandy loam. Then yung E sandy loam, yung F natin silky loam, yung G natin clay loam, yung H natin clay, and I is silky clay, and J natin is loam. So ngayon, nakuha na natin yung classification ng ating soil using the US Department of Agriculture Textural Classification Chart. So guys, dito na tayo ngayon sa problem number 2 natin. Classify the soil in AASHTO system. Yung result of particle size analysis is given. Number 10 sieve is 100% passing, number 40 sieve is 80% passing, number 200 sieve is 58% passing, and liquid limit natin is 30, at ang binigay na plasticity index is 10. So, saan ba gagamitin yan, guys? So, una, hanapin natin yung general classification. Madali lang to. Titingin lang tayo sa number 200 sieve. Ilan ba? 58%. So, dito pa lang, 35 or less of total sample passing, number 200 sieve. Then, more than 35% of total sample passing, number 200 sieve. So, 35, more than or less than? Diba more than? 58 is more than 35%. So, tanggal na to guys. Itong sa taas. Yung mga granular material. So, alam na natin yung ating general classification. Which is nandito. Sa more than 35% of total sample passing number 200 sieve. So, pag nakuha na natin yung general classification, kailangan nating alamin guys yung group classification. So, dito pipili tayo sa A-4, A-5, A-6, and A-7, and so on. So, ito. Number 200 sieve. Dapat daw 36 minimum, 36 minimum, 36 minimum, 36 minimum. Meron tayong 58. So, guys, pasok siya sa 4. So, pasok pa sila lahat. Hindi pa natatanggal. So, dito na tayo characteristic fraction passing number 40 sieve sa liquid limit. Dito, medyo magkakabawas na tayo. 40 max, 41 minimum, 40 max, and 41 minimum. So, yung liquid limit natin, guys, sa given is 30 lang. So, hindi siya pwede sa 41 minimum. Pero, pasok siya sa 40 max. So, tanggal na tong A7 natin and A5. Nandito na lang tayo ngayon sa A-4 and A-6. So yung guys, so sa plasticity index 10, dito na magkakaalisan na talaga. 10 max ba or 11 minimum? Oh, 'di ba? Pwede siya sa 10 max pero bawal siya sa 11 minimum kasi 11 is less than 10, 'di ba? So 'yun, guys, alam na natin. Nakuha na natin yung general classification and ang ating group classification which is A-4. So dito na tayo sa solution, guys. Once na makuha na natin kung ano yung kanyang group classification, punta na tayo sa solution. So ito, guys, itong table na to nilagay ko dito para madali na lang tayo mag-substitute ng mga given values sa ating formula. Yung formula nating group index. Ito, guys, tingnan nyo na lang. F200 is number 200 sieve yan, kung ilan yung passing. LL is liquid limit and PI or P is yung plasticity index. So substitute natin, guys. Sabayan nyo na lang ako, guys, para mabilis tayo. Yan, guys, 3.45 din ba yung nakuha nyo? So, yun. So, approximately equals to 3. So, ngayon, nakuha na natin yung sa solution, nakuha na natin yung general classification, at yung kanyang group classification. So, the soil will be classified as a A4 3. So, guys, thank you.
I am Pyro and Villanueva here to discuss the problems given for Module 3, compaction and field density. So for problem number 1, we have this table here. The following moisture unit weight density data are results from the Vernon compaction test. So we have two problems. Plot the curve for the moisture dry unit weight relationship and indicate maximum dry weight and optimum moisture content. So we have this table of values here, and we have a graph already set here. So first off, we need to plot the graph. So we already have a graph. As we can see, the apex of the graph sits around the water content of 14%, around 14%, let's say 14.8%. So that will be our optimum moisture content. And our maximum dry unit weight will be 115 pounds per cubic feet. So moving on to the next problem, what range of water content appears advisable in order to obtain 98% or more compaction? To get this, we need to divide the maximum dry unit weight, which is 115 pounds per cubic feet over the decimal form of 98%, which is 0.98. Now we have 112.7 PCI. So that will be around here. So to answer what range of water content appears advisable in order to obtain 98%, we need to find this range in between here. So that will be around let's see, 10.5% to our optimum water content, which is 14.8%. There. So this is the answer for A, and this is the answer for B. So moving on to the next problem, we have the sample equipment is used to determine an in-place unit weight, field density test on a compacted earth field, on a compacted earth field. Ottawa sand is used in the code and is known to have a bulk density of 100 pounds per cubic feet. We have two problems. First off is, from the information given below, determine the in-place dry unit weight of the tested soil and water content. So we have here the set of values for soil sample dug from test hole. Its wet weight is 4.62 pounds. Its dry weight of the dry weight of the soil sample is 4.02 pounds. The weight of the Ottawa sand or sample filled with test hole is 3.6 pounds. And the second problem is determine the percentage of compaction of the tested soil if the laboratory moisture unit weight curve indicates a dry unit weight of 115 pounds per cubic feet and an optimum moisture content of 13%. So the first step is we need to determine the moisture content in place of the soil. So we have the formula of the formula of the water content, which is water content is equal to wet weight minus dry weight over dry weight times 100%. So in solving this, we have 4.62 minus 4.02 over 4.02 times 100. This will give 14.9%. This is our water content. Dry weight of the tested soil. First off, we need to find the volume of the So we have this formula, which is the volume of the hole is equal to the weight of the Ottawa sand over the bulk density of the Ottawa sand. Solving, we will have 3.6 pounds over 100 ECF, and this will give a value of 0.036 square feet. And lastly, we need to find the in place. The dry unit, we need to find the dry unit weight of the in place soil. So to get that, we'll make use of this formula, which is the dry weight of the soil sample, which is 4.02 pounds, over the answer we got from the volume of the hole, which is 0.036 feet squared. And this will give an answer of 111.7 PCF. And this will be our dry unit weight of the in-place soil. So we have our 111.7 PCF. We're on to the next problem. We need to find the percent compaction of the tested soil. With a given amount of dry unit weight of 115 PCF and moisture content of 13%. To get that, we will simply use the formula of y equal So we'll use the formula of the in-place soil over the max, the dry unit rate of 150% times 100. So instead of everything, we'll get that's right. So if we solve this, we'll get 97.1% rate of convection. That will be our answer for the second problem. So for the first problem, so in summarizing for the first problem, we have water content of 48.9%, in place dry unit rate of 111.7 pounds per cubic feet. And for the second problem, we will have rate of compaction, which is 97.1%.
So good day, I am Brian and Jesus, and I am the one who presented the module 5 lesson 6.1.8 stresses in saturated soil with downward seepage. So the number one problem is consider the downward flow of water through a layer of sand in a tank shown in the figure. For the sand, the following properties are given, which is E equals to 0.48 and G is equals to 2.70. A. Determine the saturated unit weight of sand. B. Determine the effective stress at point A. And C. Determine the effective stress at point B. So before we go to all of these questions, we need to first solve the I, which is equals to H over L, which is already given, which H1 is equals to 1.2 meters and 2.5 for the remaining below L1. So we get the answer 0.48 for I. So for A, we need to determine the saturated unit weight of the sand. We have the formula, which is Y sat, or unit weight of sand, is equals to G plus E over 1 plus E times the unit weight of water. We substitute the values, which gives us 2.7 plus 0.48 all over 1 plus 0.48 times 9.81, which is the unit weight of the water. We get the answer 21.078 kilonewton per meter cube. So for letter B, determine the effective stress at point A. So we need to look first for H2, which is equivalent to, we have a formula of I times L2. We have I here that we have solved earlier for 0.48, and we have L2, which is 0.8 as shown in the figure. So we can get the answer of we have the answer 0.384 meters. So for Y2, we have 0.6 plus 0.8 minus 0.384. We have an answer of 1.016. So for computing the stress, computing the total stress, we have 21.078 times 0.08 plus 9.81 times 0.6. We have an answer of 22.748 kilopascal. And for the pore water pressure, we have 9.8 times 1.016 is equals to 9.967 kilopascal. And for the effective stress, we just need to subtract the total stress from pore water pressure, and we will have an answer of 12.78 kilopascal. And for determining the effective stress at point B, shown in the figure, we will do the same process here, which we will find and look for y sub 1, which is equals to 0.6 plus 0.25 minus 0.2, since this pipe here has a length of water downward ratio of 1.2. We will get an answer of 1.9 meters. And we will look for the total stress, 21.078 times 2.5 plus 9.81 times 0.6 from the figure. We get an answer of 58.581 kilopascal. The same for the total pore water pressure. We have 9.81 times 1.9. We will get an answer of 18.639 kilopascal. And we will subtract the total stress and the pore water pressure to get the effective stress, which is 39.942 kilopascal. So for problem number 2, figure shows a layer of granular soil where downward seepage is caused by a supply water at the top of the tank. The rate of supply is kept constant. Coefficient of permeability of soil is 0.1 cm per second, and the saturated unit weight of soil is 18.5 kN per cubic meter, and the area of the tank is 0.5 meters squared. So for A, what is the rate of the downward seepage in cubic meter per second? B, what would be the critical hydraulic gradient? And C, what value of H will cause the void? So for A, we have a formula of Q is equal to KIA, which K is already given and we all need to convert it into meters. So 0.01 is divided into 100 and I is equals to 0.8 over 1.2, which is H over H2 and 5 is A. So we get an answer of Q is equals to 0.0033 meter cube per second. For B, what would be the critical hydraulic gradient? So we have a formula here which is I equals Y sat minus YW all over YW. So we all know that YW is equals to 9.81. That is the saturated water unit weight. The water unit weight, and it is equals to 18.5 minus 9.81 all over 9.81, and I is equals to 0.886. So the final question is what value of H will cause the boiling? So we have a formula which is H over H2 is equals to ICR. So we already computed ICR from the previous question. So we all need to substitute all the values. So to look for H, we need to derive the formula. So we will have H is equals to ICR multiplied by H2. So H is equals to 0.886 times 1.2. We will have an answer of 1.06 meters. That's it.
Good day, my name is Timmy Muhammad and I will be discussing about Module 4, Seepage and Permeability. So let's proceed with the first problem under permeability. The problem is... So let's proceed with the first problem under permeability. Problem number 1. A constant height permeability test is performed in a laboratory where the soil sample is given 25 centimeter in length and 6 centimeter in cross-sectional area. Then the height of water is maintained at 2 feet at the inflow and 6 inches at the outlet end. The quantity of water flowing through the sample is 200 ml in 2 minutes. And what is the coefficient of permeability in millimeter per second? So this is our solution would look like. Then the formula that we are going to use is coefficient of permeability is equal to the amount of water over time multiplied by the length of soil sample over cross-sectional area multiplied by cross-sectional area multiplied by change in height. So we're just going to plug in these values since they are given. Coefficient of permeability is equal to amount of water which is 200 cubic centimeter over time taken which is 2 minutes multiplied by 25 centimeter which is the length of the soil sample all over 6 centimeter squared which is the cross-sectional area times 49.7 centimeter came from the height of water which is maintained at 2 feet at the inflow, and we're going to minus, since this is change in height, 6 inches will yield 18 inches, then we're going to convert it into centimeters since it is still in inches. 18 times 2.54 over 1 inch is equal to 45.72. Then our coefficient of permeability will be 9.113 centimeter per minute. But the question is, what is the coefficient of permeability in millimeter per second? So we're going to convert this value. 10 millimeter is equal to 1 centimeter and 1 minute is equal to 60 seconds. And this will yield 1.51 millimeter per second. And that will be the value of our coefficient of permeability. Let's proceed with problem number 2. A single row of sheet pipe is driven up to a depth of 4 meters in a bed of clean sand having a coefficient of permeability of 0.002 centimeter per second. An impermeable layer of very steep place exists at a depth of 10 meters below the ground level. The sheet pile wall has to retain water up to 4 meters above ground level. The height of water level on the downstream side is 0.5 meter. Then construct the flow net and determine quantity of seepage loss considering unit width of the sheet piles. So, as we can see, this would be our constructed flow net. And in the problem, it says that the sheet pile is driven up to a depth of 4 meters. And the coefficient of permeability is 0.002 centimeter per second. Then, an impermeable layer of very steep place is at depth of 10 meters below. Is from ground level up to here. Then the sheet pile wall has to retain water up to 4 meters above ground level. Then the height of water level on downstream is 0.5 meters. Then after we constructed the flow net, we are going to solve for the amount of seepage loss due considering unit weight of the sheet pile. So the formula that we are going to use is equal to seepage loss is equal to K times H, which is the initial head, times the NF, which stands for number of flow channels over equal number of head drafts. So first we are going to convert the coefficient of permeability, which is 0.002 centimeter per second, convert it to meter per day since it is still in centimeter per second. And 1 day this consists of 86,400 seconds. So after we obtain the value of coefficient of permeability, we now get the value of the initial head, which is 4 meters minus 0.5, and the number of flow channels is 7, which we can see in the flow channel that we draw, and the number of equal drop is equal to 12, which we are going to obtain in the constructed flow net as well. So after obtaining these values, we are going to just plug it into our formula. Quantity of seepage loss is equal to 1.728 multiplied by 3.5 times 7 all over 12, which yields 3.53 cubic meter per day. So that solves our problem. The amount or the quantity of seepage loss considering the unit weight of the sheet pile would be 3.53 cubic meter per day. That's all.
Good day, I am Edbert Pajarito at ang napuntang topic ko sa akin is yung Module 6, Vertical Stresses. At yung napili po namin topic is Effective Stresses. So sa unang problem ko is number 1, sea void make 2006. A thick layer of clay underlies a sand formation having a thickness of 5 meters. The groundwater is located 2 meters below the ground surface. Specific gravity of sand and clay is 2.65, with sand having an average void ratio of 0.52. The clay has a water content of 42%. So ang pinapahanap ko sa atin is letter A, compute the saturated unit weight of clay. B, compute the total stresses at C. At ang letter C is compute the effective stress at C. So sa topic na ito, kinukuha natin yung effective stress ng isang lupa para mahanap natin yung shear strength ng lupa at a certain point. Kapag mas malaki yung effective stress ng isang lupa, may sabihin mas maliit yung shear failure niya. At sinasabi po sa principle of effective stresses, kapag yung saturated soil is loaded, sabihin natin itong part na ito is yung ating saturated soil, loaded siya, tapos ang mangyayari is, yung load na yun, i-absorb siya ng water. So ibig sabihin, ang effective stress sa point C is equals to total stress minus ang force stress ng water na yan. So dito po sa ating soil profile, meron tayong dalawang layer ng lupa. So una, meron tayong sand, and meron tayong ang specific gravity niya is 2.65 and yung void ratio niya is 0.52. Ang groundwater table natin is below 2 meters lang ng point A. At sa pinakamabang layer, meron tayong clay. So meron tayong specific gravity na 2.65, tapos meron po tayong moisture content na 42%. So ang height ng sand natin is 2 meters, plus 3 meters, 5 meters, and meron din po sa clay, 5 meters. So ang pinapahanap ko sa atin is kung ano po ba ang saturated unit weight ng clay. So una, solve muna natin yung letter A. So ang formula po natin sa saturated unit weight is Y sat is equals to GS plus E times the unit weight ng water over 1 plus E. Ang problema po is wala po tayong void ratio sa plane natin. So hahanapin mo natin yung void ratio, which is yung derived formula niya is yung tinatawag natin na West, which is specific gravity times void ratio is equals to moisture content times E times saturation, degree of saturation. So given po ang tatlo natin, ang hinahanap is void ratio. So isolate po natin ang ating void ratio, makuha natin is E is equals to specific gravity times moisture content over degree of saturation, which is yung degree of yung specific gravity natin is 2.65 times moisture content ng 0.42 times ang degree of saturation natin is 1 kasi saturated siya. So compute natin yung E. So meron po tayo 1.11 Ito po yung void ratio natin. So makukuha na po natin ang unit weight ng clay natin. So Y sat is equals to Gx plus E times the unit of water over 1 plus E is equals to 2.65 plus 1.113 times 9.81 yung unit weight of water over 1 plus 1.113. So ang result natin is, unit weight natin sa clay is 17.47. So, ang next po is, hanapin po daw natin yung total stress doon sa point C. Kung magpapansin natin sa soil profile natin, ang point C natin is below 10 meters doon sa A. So, ibig sabihin, ang total stress natin is sa C is equals to total stress sa A. So, ngayon po, i-compute natin yung total stress sa C. So kung mapansin natin yung point C natin is below 10 meters doon sa point A. So ibig sabihin, ang total stress natin sa C is ipag-add po natin yung stress dito sa unang layer nito, pati ang sunod na ito, ipag-add natin po ang load. Shit. So, ang sunod po is yung sa letter B, compute the total stress at C. So, pinapalang po sa atin ang total stress sa C. So, take note na ang iba po ang total stress sa effective stress. So, ang gagawin po natin is pag-add po natin ang stress dito sa unang layer na ito, pati kaya pag-add natin yung stress dito sa layer na ito. So, let's say na ang total stress sa C is equals to ang total stress sa layer 1 plus total stress sa layer 2. So kung mapansin natin, para mahanap natin yung total stress sa 1 is, hanapin muna natin yung unit weight ng lupa nandun sa layer na yun times yung height niya. So kung mapansin natin yung sa soil profile natin, yung unang layer natin is sand. So, hanapin muna natin yung unit weight ng sand natin. Y drive. Y drive is equals to specific gravity times water, unit weight of water over 1 plus E. So, direct substitution na lang ng mga variables 2.65 times 9.81 over 1 plus 0.52. That is equals to 17.10 kilonewton per meter cube. So, take note na yung sa layer ng sand na po natin is meron tayong groundwater table. So, ibig sabihin sa layer na ito, may portion siya na saturated na. So, hanapin natin yung unit weight ng saturation na yun. Y sat is equals to GS specific gravity plus E unit weight ng water over 1 plus E. So, 2.65 plus 0.52 times 9.81 is equals to 1 plus 0.52, which is 20.46 kilonewton per meter cube. So, take note na kanina nasolve na natin po yung ating sa unit weight do sa clay, which is y sat at clay is equals to 17.47 kilonewton per meter cube. So, ipag-aantap po natin yung mga total stresses sa given soil profile po natin. So, sa unit weight ng dry natin, so times yung height niya, kung mapapansin natin sa soil profile natin, ay 2 meters siya. So, ibig sabihin, 2 meters times 2 meters plus itong saturated sand natin, which is meron siyang 3 meters na kapal. So, y sand is equals to 3 meters plus, yung sa clay naman natin ay mayroon tayong 5 meters na height. So, y sand is equals to 5 meters. So, take note, kanina nakuha na natin ang mga unit weight na ating mga soil. So, sa dry unit weight natin ay 17.10 times 2 meters plus 20.46 sa saturated sand natin ay 20.46 times 3 meters plus, so kanina unit weight natin sa clay is 17.47 times 5 meters. So, makuha po natin ang total stress sa point C. So, ang total stress po natin sa C is 182.93 kPa. So, ang pinapaalam po sa FRC is compute the effective stress at C. So, paano po natin makuha ang effective stress at C? So, sabi kanina, ang principle ng effective stress is kapag ang saturated soil is loaded, so ang loading natin is yung water natin doon sa soil profile natin, i-absorb niya yung portion ng load na present doon sa soil profile. So, ibig sabihin, yung stress natin sa C, at po na lang so, sa letter C po is compute the effective stress at C. So, paano po ba natin makukuha yung effective stress at C? So, sabi ko kanina, ang principle ng effective stress is kapag ang saturated soil natin is loaded, ang stress na yun is i-absorb ng water doon sa ating soil profile. So, ibig sabihin, ang present na total stress natin sa lupa, mababawasan siya ng force stresses. So, ibig sabihin, effective stress at C is equals to total stress at C minus the force stress at C. So, meron tayong total stress na 182 minus, paano pa natin makukuha yung force stress sa ating soil profile, sa ating lupa? So, take note na yung groundwater table natin is 2 meters below the point A. So, ibig sabihin, 2 minus 10 meters yung buong kapal niya. So, ibig sabihin, 8 meters ang height. So, yung unit weight ng ating water is 9.81 times yung height niya o yung kapal niya na 8 meters. So, meron tayong effective stress sa C na 104.42 kPa, kilopascal. This is the final answer for letter C. Let's proceed to problem number 2 sa effective stresses. So, ang problem pa natin is from the given soil, compute the following. So, aanapin pa natin ang effective stress sa B, effective stress at C, at how high should the groundwater rise so that the effective stress at C is 504 kilopascal. So, meron po tayong soil profile dito. So, meron tayong dalawang layer dito. So, may sa ating unang layer sa taas. So, may dry sand tayo na may void ratio na 0.61 at may specific gravity ng 2.66. So, meron po siyang thickness ng 4 meters. So, sa baba na naman po is saturated sand. So, naging saturated lang naman siya kasi sa taas niya is mayroon tayong groundwater table or water surface. So, ang ating void ratio is E equals to 0.48 at ating specific gravity is 2.67 na may thickness na 5 meters. So, ang unang hahanapin natin is kung sa letter A, which is yung effective stress at B. Ano daw ang effective stress dito sa point na ito sa letter B sa point B natin. So, letter A. So, ang gagawin natin is effective stress at B is equals to unit weight doon sa soil na yun times yung height niya. So, ang ating unit weight ng soil natin is dry. So, may dry sand tayo. So, ibig sabihin, y dry equals to height ng or thickness ng ating lupa. So, kung nahanapin po natin ang ating dry unit, yung unit weight na ating dry na lupa. So, y dry is equals to specifically times the unit weight of water over 1 plus the void ratio. So, may substitute the values na nakalagay sa ating soil profile. So, meron tayong 2.66 times unit weight ng water, 9.81 plus over 1 plus 0.61. So, ang y-dry natin is 16.81 kilonewton per meter cube. So ngayon, mayroon na tayo weight. So i-substitute na lang po natin ang mga given values. So sa effective stress ng B is equals to 16.21 times yung height natin is yung kapanahan ng lupa is 4 meters. So, ang effective stress natin sa B is equals to 64.84 kilopascal. So sa letter B po naman is pinapahanap po sa atin ang effective stress at C. So ibig sabihin, palamanag natin yung effective stress sa C, hanapin natin muna ang unit weight nandito at ang layer nandito. So kanina sa letter A, nahanap po natin ang unit weight ng ating dry sand and yung effective stress sa B. So ibig sabihin, ang total stress sa C is equals to effective stress sa B plus yung effective stress sa baba mo. Sabi natin, that's represented as 1. So, para mahanap po natin ang effective stress dito sa pinakababang layer. So, kung mapapansin po natin sa ating soil profile, saturated sand siya. So, pwede po natin mahanap yung unit weight gamit yung Y submerged is equals to Y saturated minus the unit weight of water. So ang total stress ng effective stress natin sa letter B is ay sa point B is 64.84. So, yung ito naman, yung variable natin ito, we can represent it as so, ang Y submerged natin is equals to Y sat minus Y unit weight of water times yung thickness niya, which is 5 meters. So, una muna natin hanapin is yung unit weight niya ng saturated soil. So, Y sat is equals to GS, which is specific gravity plus void ratio times the unit weight ng water over 1 plus the void ratio. So, substitute the values 2.67 plus 0.48 times 9.81 over 1 plus 0.48. So, ang unit weight natin is so, ang unit weight natin is 20.89 kilonewton per meter cube. So substitute the values. So effective stress at C is equals to 64.84 plus 20.89 minus 9.81 unit weight ng ating water times 5. So makuha po natin ang effective stress sa C, which is 120.24 kilopascal. Final answer. So sa level po naman yung sinanong is kung kano pa kataas dapat yung ground water natin para yung effective stress natin sa C is 104 kilopascal. So kung makikita natin dito sa soil profile natin, may mga binagawang values dito. So kung mapansin natin, may new water table tayo at yung thickness niya, yung height niya ay nirepresent ko as H. Sabay yung thickness naman ng resin natin is 4 minus H. So magtataka kayo, bakit dyan ako na ma-show ng ating height? So kung mapansin natin kanina, sa unang part natin na sa letter B, so ang effective stress, so yung sa letter C naman po is pinapala ko sa atin kung gano'n daw kataas yung ating groundwater table na para yung ating effective stress sa C is 140 Pascal. So kanina, ay ngayon mapapasin natin no, sa soil profile natin may mga binabang values. So sa una, sa letter B natin, meron tayong new water table. So meron siyang thickness na nirepresent ko as H. Tapos sa dry side naman, nirepresent ko siya ng 4 minus H. So bakit din ako nakashow ng mga values sa point na yan? So kung mapapansin natin, yung effective stress natin sa C is 120.24. Assuming na yung height na ating water table is 5 meters. Diba? So 120.24 kPa sa 5 liters. So kung mapapansin natin kanina, ang formula natin is total stress sa B, effective stress sa B, minus y sat is equals to unit weight ng water equals yung height ng water table natin, which is 5. Kapag tinaasan ko ang ating value ng height, ibig sabihin, bababa yung value ng negative stress. So, pinapaanak ko sa atin is 104 kilopascal. So, kanina, 120.24 kilopascal, assuming 5 liters. So, ibig sabihin, kapag pinakasa ko pa yung groundwater table ko, ibig sabihin, bababa pa yung ating effective stress hanggang sa makuha natin yung 104 kilopascal. So, ngayon, kukunin na po natin ang mga stresses sa lupa. So, take note, kanina nakuha na natin yung unit weight ng dry sand natin, which is 16.21. Sabay yung saturated sand po naman natin is 20.89. So, ngayon, ang kukunin po natin yung unit weight is yung dito sa water table po natin. So, ibig sabihin, itong portion ng sand na ito, naging saturated na siya. So, hanapin po muna natin ang ating unit weight para doon. So, y sat is equals to GL specific gravity plus void ratio times unit weight ng water 1C. Kilonewton per meter cube. Ito yung unit weight natin sa portion na ito. So, kukunin na po natin ang effective stress sa D, sa C. Ay, kukunin na po pala natin ang height sa given na 104 kilopascal sa ating C. So, represent muna natin ang ating mga values. So, y dry times 4 minus H plus, so take note na ito ay submerged, so ibig sabihin, ima-minus natin yung unit weight ng water. So, ang y-sat natin kanina is, so, y-sat equals to, minus y-sat minus unit weight ng water times H plus y-sat sa C minus unit weight ng water times 5. Substitute the values, 104 kilopascal is equals to 16.21 or minus H plus, so ang unit weight natin sa water table is 19.22 minus 10.81 times H plus, ang unit weight natin sa saturated sand is 20.89 minus 10.81 times 5. So, sheet solve lang para mas mabilis. 16.21 4 minus H plus 19.92 plus 89 times 5. So, ang height natin is H 2.66 meters. So, ibig sabihin ito ay 2.66 meters. So, ang total height sa above the sea is, paklasan natin yan. So dapat 7.66 yung taas na water table para makuha natin yung effective stress sa sea na 104 kilopascal. Pero ito ang pinaka-final answer natin.